I know. It's, you guys will have to excuse the right there. I'm running Windows 10, so I can't figure out how to actually activate it. So for those of you who don't know me, my name is Mike Meadows. I'm a director and competency manager of cloud and enterprise architecture at Quick Solutions. Today I'm tackling the incredibly engaging topic of security, and specifically securing line of business applications in the cloud. And I'll get to what line of business is because that's a very specific type of application that we're discussing, but it's also an opportunity space, which is why I'm talking about it here. So I'm going to start, and this always works, by the way, getting people engaged in a talk by asking them to raise their hand. So tell me this, anybody who has not done any kind of development, engineering, or provisioning in the cloud, raise your hand. I see it worked. All right, so I'm assuming the rest of you have dealt with things in the cloud in general, right? So you're kind of familiar with the fact that it's different, but it's the same, which scares the bejesus out of executives, right? Because if it's the same but it's different, why am I going to do it? In fact, the next slide here, if you guys go to NJIT, if you just actually type NJIT Cloud Security, they've got a really great infographic, and this comes from it. But this is a little telling because what it tells us here, actually, is that when you ask people who don't have a lot of experience in the cloud, what's your top concern, right? Or at least what is a top concern? 31% of them say that security is a top concern, right? And it's because, well, look, it's out there, right? It's not in my network. I don't have my guys putting it behind all these firewalls. I'm scared, right? Now, if you go over to the cloud-focused users, what you'll find is it drops down to number 5 at 13%. The difference between the percentage of people who say it's a top concern in the cloud-focused area versus the cloud security area is the percentage of the top concern, which is compliance now, right? So where I'm going to take you is what do you have to do for line of business apps to secure it in the cloud? But where I want to get you is that the things that you have to do are subtle, right? And one of the reasons I want to talk about this is they may not be immediately obvious, but they're important, right? So what is a line of business app? This is really where we should start, because a line of business app is a very specific type of application. So if you're familiar with web applications, it's not exactly that. If you work on sort of back-end applications, it's more like that, right? The difference is that your public-facing apps, if they're compromised, unless they're compromised in a really, really bad kind of way, you're really going to only lose a user's data, right? An individual's data. With a line of business application, if it's compromised, you pretty much lose everything, right? Because you assume, at least from a conventional sense in line of business application development, that your users need to see everything, right? Now, I'm going to kind of challenge that here in a little bit, but that's kind of where we start. And excuse me. It's certainly, if you ask your users, that's what they're going to tell you they need. So, a quick shorthand on line of business applications is, if you ask your user, sorry, you got to relevel. Did you turn it off? Yeah. You were avoiding the crash, right? Yeah. Good job. If you ask your users, well, what do you need to see? And they tell you, well, I need to see everything. Then it's probably a line of business app. Important things with line of business apps is that they actually support your internal business processes, right? So it's not necessarily the touch point to your enterprise. It actually is your enterprise. And larger enterprises are composed of multiple line of business applications, and those connect to each other. But fundamentally, there are critical business processes that these things implement. And the implications for security is that if these processes are hijacked or interrupted, they could destroy your business. And that's why we have to put a little bit of extra thought into these line of business applications. Okay, so programmers versus security architects. There's a little bit of a conflict here in terms of how we deal with line of business applications. While I talk, I'm going to let you guys figure out which one is which. I'll answer it here in just a second. But each of them have unique perspectives, and I'm going to kind of talk about those a little bit and how they matter. For the sake of this talk, I'm going to fall a little more on the security side, simply because I'm not talking about making usable apps, I'm talking about making secure apps. But I am going to talk about how you balance those so that you end up with a secure app that isn't so secure that it prevents productivity, right? Okay, so the programmer's world, it's my original version of this was Ada Lovelace, but I kind of modified it for the event, right? The programmer really wants to make something cool, right? So, okay, now I'm going to ask for participation. How many of you come from a development background? Okay. And then are the rest of you infrastructure? Yeah. Okay, so the majority of you here are going to be programmers, and I'll say, most programmers, if not all, want to make something cool, want to make something that they're proud of, want to make something that people like to use, right? From a programmer's perspective, a benchmark of success is you going to user and saying, hey, how was it? And they're like, hey, this is really great, right? Or looking at the stats and seeing adoption rates, right? A programmer wants to focus on functionality. And in all honesty, if you go to a programmer and say, okay, I need you to implement these non-functional requirements, right? I want you to keep people from seeing these fields, and I want you to do, and then he looks over at the guy next to him who's building, new and cool ways to get to their data and drill into it and do all kinds of cool stuff. He's gonna give you a look, and he's gonna say, like, why can't I do that stuff instead, right? As a programmer, you want user experience, right? You want to make an app that's fun to use, it's cool to use. Ignore this, right? This is a different example, but it's really about making things that people are going to like. That's why you get into it, right? I'm assuming that since you're here at a conference, you're not necessarily into this because it's a job, right? You're also into this because you like making things. So the last one, which goes a little bit against user experience, is we like data. We like lots and lots of data. So if you go do a Google image search for bad UI, I think this particular screenshot that's like the first 8 hits. It's an app called Bulk Rename Utility that basically renames files. This one my daughter gave me. I was searching for impractical armor, and inappropriate things kept coming up. Various levels of chainmail bikinis. So I had to go to my 11-year-old and get some help there, and she plays a game called Terraria, so she's like, ooh, this is good. If you ask a developer to build something that's secure, you're probably going to end up with something like that, right? Because he or she is going to be focused on the appealing and attractive versus the secure. Now, on the other side of it, the security architect, and this is how I think they all view themselves, so hence the picture. Really, their focus, and as a developer, I think a lot of us have to understand this, is that if something goes wrong, if anything goes wrong, right, it could be the thing that ends the company, and certainly ends their job, right? So for a lot of these security architects, their perspective on security is it's one or done, right? Recently I worked on a project where we had somebody who made that very, very clear every time we dealt with them. So, from their perspective, they're the protectors of the innocent, the last line of defense against, the hordes of destructive developers, the Hulks, right? So a security architect wants to focus very specifically on vulnerabilities. These are all the places where, bad things can happen, right? So let's secure them all. And what you end up with in that is that the best case scenario is nobody can do anything, right? Especially in a line of business app where it basically is the window into all of your business, right? And in that case, their focus really is security over productivity. They don't get held accountable necessarily for being able to do things fast, right? Or doing things with a smile, right? They get held accountable if they end up on the news and they lose 15% of their stock value because they got hacked, right? So it's fair to say that their job is to inhibit all of these cool things that the development people want to do. What happens, though, is that they have their own version of impractical armor, right? So, what you end up with is something that is so secure it's destructive. So I just want to show you, I was looking for an archetypical line of business application, and those of you who know me know that I love grids, so this was a great one. But it's very, very common in a line of business. So, when you look at this, you might say, okay, well, here's lots of grids, they're editable, people can do pretty much whatever they want, they're going to be productive, right? What a security architect is going to see is, oh, what, you want all of our data? No problem, here it is, I'll let you page right through it. In fact, if you want to get all of it, I'll make it even easier for you by letting you see more records, right? And they're going to say, okay, well, look, if you want to edit the data, from an auditing perspective, I don't even care why you're editing it, I'm just going to let you edit it, right? In fact, if you want to create records, I'm not going to care why you're going to create them either. I'm just going to let you create them, right? Oh, in fact, if you want direct access to our clients, I'm going to give that to you too. You just go here and you can see all the data you want. And in fact, getting to their personally identifiable information, I'll make that easy for you too, right? So if you move away from a productivity focus and you move to a security focus, you can see that all it takes is getting access, and then you get everything, right? So this is where the security architect is coming from. And so in fact, when he sees this, what he really sees is this. This was my 6-year-old's favorite slide by far, right? You want me to test it? Okay. All right, so this is what the security architect builds, right, if he has a choice. When in actuality, what he may really need, what your organization may really need, can fit in a suitcase. So it's kind of, the rest of this talk is going to be focused around, this was a little bit of the introduction into this, the practical implications of designing a line of business application and the unique challenges of a line of business application if you're going to move it into the cloud, right? So the first thing I'm going to talk about is the concepts, and particularly I'm going to focus on a technique called threat modeling. So if you're not familiar with threat modeling, raise your hand. Okay. Threat modeling is actually one of the few things that Microsoft gave us in the 90s that's still around. It's a technique for organizing and prioritizing your threats in such a way that you can iteratively solve them. Right before that, you would organizations that had to have a security focus would spend a year putting together the security before they could even start developing anything. Right. So threat modeling really helps with that. And I'm not going to, this is the first and last time I'm going to apologize. I have 9 slides that are all bullets. This is one of them. I'm not going to read through it for you. I'll leave it up here for a second while I talk about it. But I'll sort of visit each of these bullets as I do the following slides. Effectively, what threat modeling is designed to do is to protect your assets, right? And the way that your assets are threatened is obviously through threats. And then the vulnerabilities in the attacks they create vectors to that threat, right? So a threat is a potential thing, whereas the vulnerability combined with an attack is how you get to that potential, how you make that potential realized. And then a countermeasure is how you mitigate the risk of a threat vector. And then there are techniques, there's lots of ways to actually get to defining these things, and I'll talk about a little bit of those when we get to the next section. But that's sort of threat modeling, or at least the 5 terms that are important at a glance. So the first thing are your assets, right? So what is an asset? An asset is something that you have or something that you are that is important to you and may be important to somebody else, right? What I'll say is that when we're talking about cloud line of business or cloud anything else or on-premises, there's no real unique asset in this case. the decision of what your assets are very specific to your business, not to your IT infrastructure, right? These are some examples of assets. So user or client data may be an example. Personally identifiable information. It's funny because everybody worries about credit cards. In actuality, a credit card number it sells for a certain price, but the information that is needed to apply for more credit card numbers actually sells for a lot more, right? And that's your personally identifiable information. I kind of highlighted some of it: your name, your address, your social security number, your banking history, previous addresses, spouse names. All of this stuff is critically important to protecting your identity, everybody wants it, right? So even if you're not a company that has to comply to PCI, this particular asset is extremely important to your reputation and to potentially to your future. One leakage of personally identifiable information could end a company, especially if it's a smaller company. Corporate data, accounts, proprietary information, intellectual property. Think companies like or the United Space Alliance, right? Boeing and Lockheed are always worried about these things, right? China probably has everything that they've ever thought of. It is because securing things are hard, and China's good at it, right? A company's reputation, that's an intangible, but it's also really, really important, right? For a lot of companies, if their reputation takes a hit, first of all, that's going to be probably half of the executives' jobs, but it's also going to cost the company a lot of money and a lot of goodwill, right? Virtual resources, in this case, it could be things like, their cloud computing resources, right? Somebody could hijack that and run up their costs. It could be other things that are not physical, right? And then fixed assets. It's not unreasonable to think that if somebody were to get into your assets, they could actually achieve an acquisition of your physical things, whether you're a taxi company and they get you to drive their cars into a chop shop or whatever it is, right? So again, I think the thing to note here is that in terms of assets, these are things that are very specific to your business, but important, right? And threats. So I outsourced 2 slides to my kids. I've got a 6-year-old son and an 11-year-old daughter. This was his, right? I'm like, okay, well, you get to pick assets, threats, vulnerabilities, or countermeasures, right? Attacks. Well, my son's like, ooh, I'll take threats. He's like, Daddy, let's do a monster attacking a city. I'm like, okay. So I start searching for that. So no, a bat, a giant bat, right? I'm like, okay. Well, he's like, no, a bear. Like, I'm never going to find that, but I actually did. So here it is. This is his contribution. So he will forever live in history, especially since this is being recorded. So a threat is, like I said, it's a potential, right? A threat shouldn't be specific. It should be, well, if I slip to the next slide, you'll see these sort of. Well, this is actually. Let me slip ahead too. So a threat would, for example, be a compromised message transport, right? We have to worry about the fact that if somebody can actually intercept our messages in flight, that they can either change them or they can use them for their own will, right? Hijack deployments. So we can assume that if somebody is able to deploy into our cloud infrastructure, that would be bad because they could inject their own code into our applications. Unauthorized access, which is pretty obvious, but I'll get to why that's important in the cloud in a couple slides. Component failure, and loss or compromise of keys. Now, a couple of these that are important to note is that in the cloud, there's no assumption of identity, right? So if you think about, for example, setting up a database as a service, chances are that database is not in your Active Directory or in your LDAP, right? So instead, these cloud platforms or cloud services provide keys, right? Well, that key is essentially the key to your kingdom, and if somebody can get that key, it's better than a username and password because they have unfettered access to everything, right? And then compromised message transport. is also more important in the cloud because you have to go over the internet. You don't have much of a choice. Now, when I say you don't have much of a choice, you do have some choices. Amazon has what they call Direct Connect, and Azure has Express Route, right? And both of those actually provide a tunneled connection from your business into their cloud data center, right? So you can pick a data center, and then they will give you a direct tunnel that doesn't have to go through the internet, right? And you're lucky if you get that. I'll kind of talk about that in countermeasures. Assuming that you don't, though, you still have to worry about all these other things. All right, so vulnerabilities. You guys know who this is, right? Smog, yeah. So I just want to highlight this because this is probably what I spent the most time on in this presentation. That's his weak spot, right? So there you go. So vulnerability is a way to realize the potential. So if we'll take the smog example, right? So for smog, a threat, an asset is his life, right? A threat is that his heart is a single point of failure, right? The vulnerability is the chink in his armor. So a vulnerability is a way to make a threat real. And it's something that's already in your structure, right? You built it in, it's in your architecture, it exists, so you have to acknowledge it. Now, I'll talk to you a little bit on how to prioritize those vulnerabilities. So a chink in your armor may not be as big of a vulnerability as having your heart located external to your body, right? But it is still a vulnerability. Okay. So in the cloud, we have a few vulnerabilities which you got to think about, especially for line of business applications. Unauthorized access to management portal. This guy is so important because the management portal is essentially your single point. Like if I wanted to hack your cloud account, that's where I'd go if I could, right? Because you can provision, you can destroy, you can do anything you want to these VMs short of actually getting the passwords to get in, right? You can get the keys, you can open up their network if you can get into that management portal. So that is a huge vulnerability in the cloud, and there are ways to work that, right? I mean, it's not necessarily that oh gosh, we're doomed, but it's something that you have to acknowledge as a vulnerability. It is unique. It's not necessarily unique. You may have management portals on-premise infrastructures, but it is a unique problem with clouds in general. Uninhibited access to application data. So again, assuming that you don't have something like ExpressRoute or Direct Connect, the fact of the matter is that if you get hacked with an on-premise line of business application, if somebody wants to get it to your data, it's not like in the movies, right? Like how many movies does the computer guy give a thumb drive to the person who's going on site, right? You just plug this into their server, and the guy goes plugs it into the server, and you got the guy back. You got the guy back in the van. He's like, okay, hold on. Oh, 2 more minutes. 2 more minutes. In order to get all of the data, you've got to farm it somehow, right? And as far as a line of business applications goes, if you can't get into the database, we're talking about screen scraping, right? And if you're talking about screen scraping, we've got to understand what those screens are. We've got to write a program that scrapes it out. It may not take that long, but you can't do it blind, right? Now, for a cloud line of business application, the assumption is that if you have, say for example, if it's just protected by a password, you have a username and password, you have all the time in the world to figure out how to scrape that stuff off, right? Because you don't have to be on site. There's nobody that's going to walk by and say, hey, you don't look like you belong here. So that becomes a particularly important problem to think about. Ineffective password protection. This is also, when I say ineffective password protection, I'm not talking about, it's got to be at least 50 characters with, a mix of, a third of each, capitals, letters, lowercase letters, and all that other stuff, right? I'm talking about the fact that, if somebody's working in a site that you can't control and they stick their password under their keyboard, now you don't have to actually breach the perimeter security to get that. You may just walk into their living room and flip over their keyboard and see it, right? Disgruntled employees, it's a similar problem which is that employee now, if he wants to steal all of your data and sell it to somebody, he may be able to do that in a place where you can't see, right? And then poorly configured endpoints is the final one, which is a little self-descriptive. You end up with more endpoints, and I'll flip back to the other two slides. Oops. Oh, I skipped them all together. Okay, there you go. You end up with more endpoints in a cloud line of business application simply because you have more surface area. So I'll get back to these a little bit. Well, I'll describe them now, but I'll get to the tool that I use for this. This is a boundary model for threat modeling, right? And basically, when you identify your threats, what you do is you simply say, these are all the components involved, right? So for a typical line of business application, and I've built a kind of simple one here, you've got your user, you've got your application, and you have a role database and an application database, and your logs, right? That's it. And you assume that all of this is behind a firewall, so you have the internet's not participating in this at all. There's 1, 2, 3, 4 points of connection, right? It's easier to quantify, it's easier to secure, and you also don't have that problem that basically if I can access this through the internet, I can do anything I want, and I can take as long as I want to do it, right? This is your typical simple cloud application. I added this non-relational database and cache. You don't have to have them, but I put them there. But you've got your line of business user who now has to go over the internet, and this is just a big bubble of I don't know. On the other end, it's received and it's verified, but you've got this much larger surface area of the internet, and you tend to use, because cloud providers tend to use well-known protocols like JSON, REST protocols, a little less SOAP, but protocols that are easy to read, easy to figure out. You also have this additional bit of surface area that you have to worry about. And if it's not secured properly, these internal subnetworks are also exposed. Okay, sorry to jump back and forth. If you haven't guessed, this is the one my daughter contributed. So attacks. To revisit the smog example, if your asset is your life, your vulnerability is your heart, or I'm sorry, your threat is a pierce to the heart, your vulnerability is a chink in your armor, the attack is Bard standing there with a bow, right? So that's essentially, an attack is a way to actually take advantage of a vulnerability. They're also called exploits. And what I'll say here, I struggled to come up with something that's truly unique to cloud line of business applications. For anyone who's worked on web applications in general, these are all not new, right? They are new to line of business applications, because most line of business applications are internal. They don't have to worry about these problems. They are now problems that you have to worry about in a line of business application. So I'm not going to spend too much time on those. I will skip to countermeasures. I love this, by the way, so I'm just going to let it play for a minute while I drink. That's an AC-17, by the way, firing off flares. I'll bet that makes a lot of noise. Okay, so now to revisit the smog example, we've identified the vector, right? The vector is shooting a bow through the chink in his armor. What is his countermeasure? Well, probably if he just had a simple chain shirt over that little chink, it would have been enough to deflect the shot, right? Countermeasures aren't necessarily focused on completely eliminating the vector. It's simply reducing the likelihood that anybody would succeed if they tried to take advantage of that vector, right? So we talked about express route or direct connect. Sort of lighter weight version of that is site-to-site VPN, which basically secures the connection from point to point from your premises to whatever the cloud data center is. Whitelisting IPs is a good way to take care of that management portal problem. So even if you don't have site-to-site VPN, even if you don't have a direct connection, you could at least say, hey, look, I don't care if you put your username and password in, you can't get to this management portal unless you come from this IP, right? Multi-factor authentication, So this is a problem that we're not unfamiliar with for user apps, for banking apps, things like that. Basically, it's not just your password. Maybe it's a code that gets texted to you, or it's something else that we've shared. Line of business apps, it's not as common. It's because the assumption is you're already inside our network. You're already on a computer that we approve. We're going to let you in as long as you give us your password. Sometimes you don't even have to do that, right? So when we move away from that site security umbrella, we do have to worry about multi-factor authentication. It could be RSA keys. It could be any number, any way to basically say there's a second step, right? Risk adaptive access control. So who's familiar with this concept, risk adaptive access control? This is something that a lot of people don't talk about, but it's actually pretty cool. Okay, so typically, and this is very common in apps across the board, we use role-based access control, right? So basically, if you belong to this role, you can go to this screen. If you belong to this role, you can see this field. If you belong to this row, you can click this button, right? What that doesn't do is it doesn't allow you to programmatically respond to risk. So what RDAC does, or RADAC does, is it says, okay, well, we're not going to really worry about roles. What you're going to do is you're going to tell me I want to do this, and then I'm going to understand on the back end whether or not you're allowed to do this, right? So if you think about the example where I showed you that you could page through all the data, and in fact you could expand it so that you could see more of it. Under risk adaptive access control, what it would say is, okay, well, I understand as a human that considering the workflow that you're trying to accomplish, that you only ever need to see this many records at a time, or this many records in an hour, right? And what we can do now is we can program that to say, okay, well, look, I'm going to let you see anything you want, but if you pass this threshold, I'm going to slow you down, right? Or maybe I'm even going to stop and make you go to somebody else and have them release that, right? So you got to pick up your phone and call your manager and be like, hey, look, I'm really trying to do this. Can you please release my control, right? It allows you to start to build intelligence into how we grant access into our data, into our systems. It's a pretty powerful concept. It's also more work, right? So again, if we go to the whole Hulkbuster versus Mark V, the slide where I showed the suitcase Iron Man versus the big giant Hulkbuster, if this isn't what you need, don't do it. But if it is what you need, it's a very, very powerful solution. It also, and it's not necessarily on an individual basis as well. You could say, okay, well, let's say that, the terrorist threat level goes up, right? If you have a system that cares about that, it may start locking down access, right? Command query response segregation. What that does is it simply says, look, I'm not going to let you directly manipulate my data. If you want to do something, issue a command, right? If in that command, it's contextually going to have an intent built into it, right? If the command is, onboard new customer, I can build a workflow into that if I do it as a command. If I allow direct manipulation of the data, then I can't, right? I can't. First of all, I don't know what you're trying to do, so I can't log it. If I'm doing RADAC, I can't, I can't respond to that request intelligently because I don't know what you're trying to do, right? So, one easy way to control your users and the data that they access, the things that they can do to your organization, is to funnel them through commands. Now, I can tell you that CQRS, having tried to implement it, it requires frameworks, so it's also work, right? So, each one of these things is sort of piling on to the non-functional bloat of your system. Least privilege is another one. Basically, the idea is to start with the assumption that logging in is great, right? You've logged into our system, that's great. You can see some things, but the things that you can see are the things that don't really matter, right? They're assets that we don't care that much about. And if you want to do something else, you have to request to the system, hey, look, I want to do this extra stuff, right? And then the system is allowed to grant it. But until then, we start with the assumption that every user is allowed to do very, very little, right? And then approval workflows I kind of talked about a little bit in terms of the risk adaptive and command query response. So these are just some countermeasures, right? Really, the question about countermeasures is specific to the vector. But these are some countermeasures that I think are particularly effective in cloud line of business applications. OK, so tools and tips. This is the final section. Then it's coasting till the movie starts. Microsoft threat modeling tool. I showed you a little bit of the model part of this. This is a really, really wonky tool, right? But in terms of if you have to build a threat model, this is way better than Visio. And one of the things that it does is it actually understands your boundaries. It understands your components and your boundaries and the connections. And it generates its own it generates its own threats for you, and it gives you a way to manage them. Now, what I can say is that's great for the things that are in here, but it's also not really the best way to do it. And I'll kind of show you the next thing, which is sort of the widely accepted best way to manage threats. So this is good for diagramming, not necessarily as good for managing threats, especially because it doesn't really have the contextual vectors built into this, right? It simply identifies the threats, but doesn't allow you to associate these threats with vectors. The next one is what's called a sparse grid. And there's a few different ways you can build this. You could actually have asset, threat, vulnerability, attack, countermeasure. But that's a lot harder for your business people to understand. So what's more common is this who, what, where, when, why, how, impact, and mitigation, right? And the reason it's called a sparse grid, and the one thing that I didn't really highlight about threat modeling is that it's iterative. So when you do threat modeling, you focus on the most important things first, and you leave the other stuff for later. And so you don't try to tackle your entire security architecture at once, right? And the reason the sparse grid is really good for this is the things that are the most obvious go in here first. And you don't have to fill out the entire column, right? So basically, if you think in a brainstorming session, if you're looking at one of those diagrams that I showed you before, excuse me, you may come up with some hows and some whys and some whos and wheres, and you just fill in the sparse grid, right? And once you've done that, I'm going to show you how to prioritize them next. You can start to fill in some details, and you can focus in on some of them. You can leave it mostly sparse, but you can say, okay, well, look, this one, for example, access to the management portal seems pretty important to us, right? So let's score that and let's see how it turns out. The way that you do that is called dread. So dread is damage potential. Damage potential is essentially, hey, look, if this threat actually occurs, if it's realized, regardless of the vector, if this threat is realized, how bad could it be, right? Reproducibility. So there's a big difference in terms of the value of a threat if it can only be done, once every third Thursday after the vernal equinox versus you can do it at any time and any day, right? So if you can do it any time, any day, it's probably a 10. If you can do it, under very, very strange conditions, it's probably a 1. Exploitability, again, there's a big difference between, can you do this on Raspberry Pi, or do you need a quantum computer to do it, right? If you need the quantum computer, it's probably a 1. If you can do it on the Raspberry Pi, it's probably a 10. Affected users. For a line of business, this is a little different. I wouldn't say it's necessarily affected users, it's affected data. So if this threat were realized, what is the extent of data that can be gotten to, right? And the discoverability is how easy is it for somebody to figure out? I mean, if you've got to have a deep, intimate knowledge of the application, the network, the configurations, the deployment scenarios, then it's a 10. If my 6-year-old son could figure it out, it's a 1. Or I'm sorry, opposite. Yes. So it's a 1 if you really have to know what's going on. It's a 10 if anybody could do it, right? So the formula is simple. You just add them together and divide it by 5. And that gives you a single number that you can use to rank these things. And that's actually important because you want to tackle the ones with the highest scores. If your average risk is 3, and you've got a 2, you probably don't have to worry about that one. But if you've got a 10, you probably do have to worry about it, right? So this kind of gives you a mechanism, at least from your gut, to start figuring these things out. All right, so pro tips. It's very, very, very important once you move into the cloud to assume that your system will be compromised, right? Not to assume that if you make a mistake, it'll be compromised. It will be compromised. If you look at Chase Bank, they invest billions with a B in their security, right? They got hacked. Now, I think that was last year, right? What's important to note out of that is that was a story and then it disappeared, right? We're still talking about Target and Home Depot. With Chase, it was just a thing, right? They got hacked. That's okay. It was nothing important. We got it under control. We know what they got. We're cool, right? End of story. Nobody got fired. The press stressed out about it for a little while, but then they got calmed down. But on the other hand, the Target CEO lost his job. The CIO, I'm sure, lost his job, right? And Target took a huge hit for their business. I mean, they're still recovering, and they probably still will be recovering for a couple years, right? If you assume that it's inevitable that your system will be compromised, then you can start to focus on the important things, which is if you do get compromised, how do I minimize the damage, right? So, and that's this third slide or third bullet right here. Eliminate your exploits if you can, but you probably won't be able to, right? So, if you've got a threat that's maybe like a 3 4s, at 2 10s, if you could just drop those 10s to 6s, you might be okay, right? So, don't put yourself in the mindset that look, if you can't eliminate all your threats, you've failed, right? If you can get everybody to accept the fact that you will get hacked, then you can start to focus on making sure that that's not a big deal. Prioritize your threats, we talked about. Iteratively reduce your risk, we've also talked about. That's important. Getting everybody on board with the fact that you don't stop designing your security is an important fact. Your developers are going to like it because they can focus on being as productive as possible, and you just sprinkle in some non-functional requirements for them every once in a while. Minimize your exposure by providing users with only the data that they need. I've covered that. Automate decision making. So, back to the grids, and I was being sarcastic when I said that people who know me know that I like grids. Grids are the worst, right? Because grids make no assumption about what you're trying to do. They simply say that, look, you as a user probably know best, so I'm going to give you some buttons to click, and I'm going to give you some data, and what you do with that data and how you decide to click that button is out of my control, right? The problem with that is it makes it impossible to shield your data from the world, right? Because now you have no understanding of how that data is being used. If you start to approach building your system from the perspective that the system should be automating the decision making and presenting the users with the minimum amount of information required to make that decision. And if they do require more, then escalating that so that they can get that additional information, but nothing additional, right? So, if you start to take that approach into building your systems, then it becomes much easier to audit what's going on, it becomes much easier to control what's going on, and it becomes much easier to minimize the damage in case your system gets compromised. All right, so this is also a pro tip. You have to understand that your biggest problem is not your system security, it's not your application design, it's not your infrastructure, it's not the cloud, it's not your firewalls. It's not a artificially intelligent robot that wants to cleanse the earth of humans. It's your users, right? Your users are your largest attack vector. Why? Because users are guaranteed not to care as much about security as even your developers, right? Once you realize that, once you understand that, you start to understand that you can't change their behavior. If you try to change their behavior, you're going to fail, right? An example of this is, I mentioned password complexity earlier. How many of you have had to deal with a system that had ridiculous password complexity? Yeah. So what do you do? I mean, if you don't have, say, LastPass or Password Vault or whatever those things are, right? What do you do? I mean, if it comes down to, hey, it's going to be impossible for me to remember this, and I've got to reset it every 10 days, you write it down, right? So the harder you try to get users to be secure, the more dumb things they're going to do, right? So what you should do is design your application to encourage, not expect good behavior. Right? Design your application in such a way that it naturally allows them to do things that are secure, right? And you get some pushback from them initially, but if you can win them over, this is a way to build a secure application that actually promotes productivity as opposed to inhibits it, right? And then, finally, which is sort of an underlying theme here, balance trade-offs between security and productivity. If you do not balance these trade-offs, you will either end up with a system that is too secure and is not productive, or a system that is too productive and not secure, right? And there is a middle ground. Don't sort of entrench yourself in this idea that it's got to be secure, or damn it, security is keeping me from building something that they want. And with that, conclusions. I've talked a lot about cloud line of business security. There's nothing fundamentally different, as you've seen, with regular line of business security. It's subtle. It's subtle, but it's important. And understanding the differences will allow you to sort of make those subtle tweaks. I'm not necessarily talking about, you got to go out and go through this entire education and re-engineering of all your applications. There are some things that you have to think about, though, in order to make sure that you're accounting for these differences. And finally, to use modeling as a way to visualize and determine what these differences are. And that way you can prioritize your risks. So with that, I've reached the end. And this is me, not that. This is me. I'll get these slides out. I worked on them till the last minute, so if you want to follow me on Twitter or just check up on it, I'll try to get those out in the next day. Questions? Yeah, how soon can we get to the movie? Yeah. Uh-huh. Okay, yeah, so the question was about password complexity and length in particular, and the assertion that a long password that's easy to remember is better than a short, complex one. That's true. I don't have a strong opinion about passwords. I tend to think of passwords as being the least useful security measure, right? So, if you think about a password, and again, with the assumption that your users care a lot less about security than you do, chances are, and I'll bet you, I'm not going to ask you to raise your hands, but I'll bet you every single person in here has used a password on some crappy internet site that they've also used as their AD password at some point, right? So, passwords are a great first line of defense for authentication, but that's really where it stops, and that's why I say, elevating security, elevating access is important, because you should assume that a password means nothing besides giving you the general sense that this person is who they say they are. Now, that being said, yes, long passwords, a phrase is a better way to put a password into a site than something short and complex with character substitutions. I would say that, in terms of encouraging users to do the right thing, this is one of those scenarios where, it's funny. I was frustrated. Actually, American Express, in case anybody wants an example of how not to do security, the American Express website, if you have a card and you're using it, limits your password to 19 characters. And I'm thinking, why would you do that, right? If you want to encourage them to do the right thing, then let them make it as long as you want, right? I mean, I use LastPass to make it 50 characters. So you're right that longer but easier to remember is okay. Longer and random is even better, right? So, I would say, fundamentally, just understand that password really means very little in terms of security. Yeah. Okay. Is there any other questions? Okay, well enjoy the movie because I think it's going to be cool.